Hi, we are Group 2. Today we are going to demonstrate our smart car parking system. At the first stage of building this system, we used a potentiometer, a breadboard, a LCD panel, an Arduino board, an ultrasonic distance sensor, and a 220 ohm resistor to build this system. For the coding parts, firstly, we define the data pin 7 as the trigger and echo pin of the ultrasonic distance sensor. In the function called check slot, we use this function to generate a pulse so that the sensor will keep on detecting whether there is a car occupying the parking space. And in the setup function, we define that there's a LCD panel will be used. And in the loop function, firstly, we define the distance variable and gets the value from check slots, which I had mentioned about. It is the function here. And then after that, we clear the LCD panel and then set the cursor as the first row and print number of slots. And then we move the cursor to the second row. And in the if case, if the detected object was within 2 cm to 300 cm, it means that a car is occupying the space. And this moment, the LCD panel should display full in the second row. Otherwise, it will keep on displaying 1. And for this loop function, it will keep updates every 3 seconds for updating the LCD panel. Now let me start the simulation. Now we can see that the LCD panel was switched on. It is because the potential sensor had been switched on. And then we can see that now the car park was available for parking, and there is 1 parking slot. And because there is no car occupying the space, so that there isn't any changes for the LCD panel. Let me now move the object into the range. So we can see that after a car is occupying the parking space, the LCD panel will be updated, and it will change from 1 to full, and showing that there isn't any parking slots for parking, because the parking slots had been occupied by a car. And after the car leaving the car park, the LCD panel will be updated and the full will be changed to number 1, and it will be available for any cars to check in the car park. Let me now pass the time to Jasmine, and she will talk about what we had changed in this original hardware simulation.
Hello, I'm Yipai Jasmine from Group 2. I'm going to introduce the improved circuit prototype of our system, which is based on the version that Sophia has introduced before. So for this version of our system, we're still having the Arduino as our microprocessor and the LCD panel for displaying message. So what we have updated is that we are now having 2 ultrasonic distance sensor of our circuit, and also we have added 2 red LED into our circuit. So why we are having this kind of update is that we would like to simulate the situation of the car park, since we all know that the car park is not just having one parking spaces. So if we would like to display the available parking spaces of the circuit, we should have more than one sensor to calculate the remaining parking spaces. So for the pin assignment, we are having the pin D8 from the microprocessor to connect it to the second ultrasonic sensor. So we are also update the code of our system. So we are now having a new integer value, ultra pin 2, which is to determine that the pin 8 of the microprocessor is connected to the second sensor. So we are now having 2 Boolean value, slot 1 and slot 2, to determine that the parking slot is available or not. So if it is equal to false, which means that the parking spaces is available. If it is true, it means that the parking spaces is occupied. So for the function check slot, we are now need to input the pin parameter to determine which parking spaces we are now checking. So the return value is the distance between the object and the sensor. So the distance value we can apply it into the check space function for checking and determine that the slot is true or false, and to determine that the parking spaces is available or not. So check total is to check the total number of the available slots with the Boolean value of slot 1 and slot 2. And the LED function is to control the LED on off with the Boolean value slot 1 and slot 2. So inside the loop of our system, we can see that we should check the slot 1 and slot 2 first with the check space function and the check slot function. So after checking 2 Boolean value, we should determine the LED signal and also calculate the total number of the available parking spaces. So let's move on to the demo part. So after we start the simulation, you can see that the number of slots is 2, which means that there are 2 available parking spaces inside the car park. So if we occupy the parking slot with the car, you can see that the number of slots is decreased by 1 and the LED is turned on. And also if we move the object in front of the sensor one, you can see that the number of slots right now is full, which means that all the parking slot is occupied by the car. So if we free the parking spaces, you can see that the number of slots is increased. And also, if we also move out the object in front of the sensor, you can see that the number of slots is become 2 right now, which means that all the parking spaces is available right now. And also, the light is turned off right now.
Hi, I'm Tommy. I'm going to talk about our web system. Since I mentioned in the report, we decided to focus on implementing the web system. So we merged the mobile application and the web system into a responsive web application. So you can see this is how the main page of the web looks like. It didn't have so many things implemented yet, but you can still see the parking slot as stated. We have 3 empty slots and a table-like map here. Just pretend it is a map first, so we can know about the actual parking slot will have what empty slot here. The red one implies that this is occupied. So we have 3 empty slots here, 3, 4, and 5. And also the number here shows the empty slot, just for easier for people to read. So I have made a sending function here, so you can see the changes of the data when I insert the new data into the database. So now this is the message about the insert success. So we have now only 1 empty slot in the parking slot, and now all the slots are all occupied. About the responsive, if I scale or change the window size, you can see that the element on the web page also change their position. So this is how the responsive web is designed. It is a reload button. If I change the data on somewhere, then now I click the reload button. Now you should see the data will be changed. So I have also doing some error handling. So what if the web system is disconnected, and now we click the reload button. Now there will be a warning message shown on the web page. So this is all about the web system. What I have implemented yet here.